Hello and welcome. Today we are going to demystify a topic that is the absolute foundation of all modern computers, smartphones and digital electronics. That is Boolean algebra. To download our electrical engineering app, you can visit this website link electrical-engineering.app. It is especially designed for electrical and electronics engineering students and teachers. It might sound complex, but at its heart, it's a very simple and powerful system of logic. Let's break it down using this chart. So, first of all, what is Boolean algebra? So, Boolean algebra is the mathematics of logic. Unlike regular algebra, where variables can be any number, in Boolean algebra, variables can only have one of two values, either true or false. So, in electronics and computer science, we represent these as 1 for true, 1 is for true, and 0 is for false. Now, as the image shows, there are three fundamental operations you need to know. Think of these as the addition, multiplication and negative of the logic world, that is inversion. So first of all, logical addition, plus or. This is the or operation. It asks the question, is at least one of these condition true? For example, 1 plus 0 is equal to 1. So true or false is true. Only need one true for the whole thing to be true. That means if there is only a single 1, that means the output will be 1. Then next is logical multiplication or AND operation. This is the AND operation. It asks, are all of these conditions true? That means the answer to be true, all the answer should be true. That is 1, 1. Then next is logical inversion or NOT operation. This is the NOT operation. It simply flips the value. It means the opposite of. So if the bar represents A bar reads as A bar not or not A. If A is true, then A bar is false. So if we give input as 1, we get output as 0. If we give input as 0, we get output as 1. Now, the laws of Boolean algebra. Here we can see in this table. Now let's look at the rules of the game. This law help us simplify complex logical statements, which is essential for designing efficient computer circuits. We will go through them one by one. Notice the table is split into AND form and an OR form. So first of all, identity law. The identity law tells us how to use 0 and 1 without changing the original variable. Now here we can see OR form. So 0 plus A is equal to A. So OR false equals A. If you combine a variable A with false, that is 0. The result is just whatever A was. If A is true, the result is true. If A is false, the result is false. So adding 0 has no effect. So this is for OR form. Now for AND form. AND true equals A. So here we can see 1 into A is equal to A. Similarly, if you combine a variable A with true 1, the result is just A. Multiplying by 1 has no effect. So it is like 0 plus A is equal to A. Now here 1 into A is equal to A. This is called as identity law. Then next is null law. So the null law shows how a variable can be annihilated or made irrelevant. So first we will see for OR form. So it will be 1 plus a is equal to 1. So a OR true equals true if one part of an OR statement is already true. The whole thing is automatically true no matter what a is. Then for AND form, here we can see 0 into a is equal to 0. So a AND false equals false if one part of an AND statement is false or 0. The whole thing is automatically false no matter what a is. So 0 into anything is 0. It is like that. Then idempotent law. So a into a is equal to a. So idempotent is a fancy word that means doing something multiple times has the same result as doing it once. So for OR form, a plus a is equal to a. That means a or a equals a, asking is it raining or is it raining is the same as asking is it raining. So then in case of AND form, a dot a is equal to a. And a equals a, this is just a straightforward. Then next is inverse law. It is also called as complement law. This law deals with combining a variable with its opposite, its inverse or complement. Here we can see this is a and this is the complement or inverse of a. So it will be equal to 0 in case of AND form. And in case of OR form, it will be a plus a bar is equal to 1. So again, OR not is equal, OR not a equals true. A statement and its opposite can't both be false. One of them must be true. For example, it is either raining or not raining. The combined statement is always true. Then for AND form, and not a equals false. A statement and its opposite cannot both be true at the same time. It cannot be raining and not raining. The combined statement is always false. Then next is commutative law. So this is a familiar ones from regular math. It says the order doesn't matter. So a dot b is equal to b dot a in case of AND form, and in case of OR form it is a plus b is equal to b plus a. Then next is associative law. This law also comes from regular math. It says that when you have 3 or more variables with the same operation, you can group them in any order. So here we can group them like this: a into b in bracket into c is equal to a in bracket b into c. So we can group them in any order in case of AND form also and in case of OR form also. Then next is distributive law. So this is a crucial one for rearranging expressions. It shows how AND and OR interact. So it is for AND gate or for AND form. This works just like a regular algebra, a and b or c. So here it is same as a and b or a and c. Then for OR form, This one looks a little strange to us from regular math, but it's perfectly valid in Boolean logic. It's a key tool for simplifying expression. Then next is absorption law. So this is a powerful simplification shortcut. It says that a more complex expression can sometimes be absorbed into a simpler one. So here for OR form, a plus ab is equal to a. Think of it, if a is true, the expression is 1 plus 1 into b, which equals to 1. If a is false or 0, the expression is 0 plus 0, which equals to 0. In both cases, the result is just a. The ab terms get absorbed. So this ab terms will get absorbed. Now in case of AND form, similarly, if a is true, the expression is 1 into 1 plus b, which is 1. If a is false, so it will be 0 plus b. It will be 0 into 0 plus b, which is 0. The result is always a. Then next is De Morgan's law. So De Morgan's law are superstars of simplification. They tells us how to handle the negation of a complex statement. The easy way to remember it is break the line, change the sign. So break the line, change the sign. So first law, here we can see overline a dot b is equal to a bar plus b bar. To negate and statement, you negate each part and change the and to an or. Then second law, overline a plus b is equal to a bar dot b bar. To negate an or statement, you negate each part and change the or to and. So conclusion, and there you have it. These are the fundamental rules that govern all digital logic. By understanding the basic operations and or not and these powerful laws, engineers and programmers can design and simplify the complex circuits and algorithms that power our modern world. From the simplest light switch to the most advanced AI, it all comes down to these principles. So don't forget to like, share and subscribe to this channel, and thanks for watching.